We continue our journey through electricity with a brief detour into magnetism, which is not really a detour. So we are in Module 2, which is on voltage. And what we're going to talk about in this video is the nature of magnetism. Why, you ask? Because when we ask how electricity is made, by far the primary method that societies use to generate electricity is by using the magnetism, a magnetic field that can be created by mechanical energy. Well, what does that mean? Well, basically, we can burn coal, we can burn natural gas, we can create heat by nuclear reactions, and this heat can be used to create circular motion or to create motion, and that circular motion can be used to generate electricity. We can also do it with water, like at a hydroelectric dam, where maybe you have water that turns a wheel that again generates a magnetic field that generates electricity. I did just a couple weeks ago. I looked up the number one way of generating electricity in Indiana, where I live, and it's, believe it or not, it's still coal. It's still burning coal that creates motion, that creates a magnetic field that is used to generate electricity. And so this use of mechanical energy to create magnetic fields, to create electricity, is far more prevalent way to generate electricity than a battery. So in the previous video, we talked about how batteries use chemical energy to generate electricity, but that's way less than the use of mechanical energy to generate electricity. We have a lot of solar. Solar is on the rise, which uses the rays of the sun to generate electricity. That still is not anywhere close to the use of mechanical energy to generate magnetic fields to generate electricity. So that's why it's relevant. Why is it relevant for us to talk a little bit about magnetism? Because a magnetic field is the primary way that electricity is generated. So your basic magnet is actually quite similar to the way a battery works with electricity. And like I said, magnetism and electricity are actually related forces. They are different manifestations of the same electromagnetic force, as it were. So these are imaginary lines here, but they are lines of force. We might call them lines of flux. Flux is the Latin for flow. So you might say that magnetism is flowing out of the North Pole. These are the poles, the North Pole, the South Pole. Magnetic force flows out of the North Pole and into the South Pole. Inside the magnet, it goes from south to north. Remember, this is very much like a battery, right? Electricity goes out of the negative and back into the positive. And inside the battery, you've got chemical things going in the opposite direction. So these are lines of magnetic force. I didn't draw the arrows on the top too, but it's the same. Lines of magnetic force or lines of flux. And you can see this. You can actually see it if you take an iron like this, a magnet like this, and you sprinkle some iron fillings on it. The fillings will kind of line up in accordance with the lines of force, lines of magnetic force. You can actually observe the magnetic field if you use, say, the electric, the iron fillings. Okay, so that's the basic magnet. This is probably no surprise, stuff. Yeah, I know what a magnet is, right? Well, there are 6 basic rules of magnetism, and that's the heart of this video. So here they are, ladies and gentlemen, the 6 rules of magnetism. The first rule is that magnetic lines of force, they form closed loops. If you look on this video, you can see that all of these loops go all the way around. They don't stop. I'm halfway there. I'm tired. I'm going to stop. No, magnetic lines of force form closed loops. They pass through all materials. So it's like they pass through your hand. This is why we can use, for example, magnetic resonance spectrography, I think it is, to look inside you, because the magnetic field goes inside. You a lot of times when you use that kind of a tool, you will drink something that has a substance that is affected by a magnetic field, and therefore the magnetic resonance spectrography can see kind of how those magnetic things inside of you move, as it were. So magnetic lines of force pass through all materials. 3, they try to form the smallest loops possible. So they don't go, when you look back at this diagram, it doesn't go, no, it doesn't do that. It tries to form a nice, tidy, small loop, the smallest loops possible. They don't take detours. Unless number 6, no, actually, next slide. Forget I said anything. We'll get there next slide. 4, magnetic lines have a polarity. There is a north pole, there's a south pole. It comes out and it goes in. So there is a polarity. The poles have an orientation, as it were, in relation to the magnetic field. 5, they enter and leave the poles at right angles. So you see, they come out at right angles. They may immediately go a little bit circular, or elliptical at least, but they come out of the poles and go into the poles at right angles. And then 6, like poles repel, opposite poles attract. So if you try to put 2 north poles of a magnet together, they're going to push away. But if you put a north and a south together, they're going to connect and hold. So these are the 6 rules of magnetism. Magnetic lines of force form closed loops. They pass through all materials. They try to form the smallest loops possible. They have a polarity. They leave the poles of a magnet at right angles. And like attract, it's like electricity, right? Like attract and opposite repels. So there you have it, the 6 rules of magnetism. Finally, a few odds and ends here. The measure of a magnetic field is its flux density. So if you're drawing it, the closer you draw the lines of magnetic field together, that's meant to represent a denser magnetic field and thus a stronger magnetic field. So the measure of a magnetic field is its flux density. Some materials are more attracted by magnets than others. Plastic, not so much. Iron, very much so. That's why we use the iron fillings to see where the magnetic field is. We don't use plastic fillings. So some materials are more attracted by magnets than others. And then magnetic materials distort the magnetic field. So if you have, if you have 2 magnets next to each other, they're going to interact with, their magnetic fields are going to interact with each other and will distort an otherwise nice and tidy field. There you have it, the 6 main principles of magnetism.